Right. Okay. Well, thank you again. Thanks for turning up, and good morning, everyone. Welcome. Um, this webinar is on the back of a building publication or handout that BCSA produced, focusing on the costing steelwork series that we routinely do in Building Magazine. And then towards the back of that, there was a short article I wrote about embodied carbon and embodied carbon targets. So really, that's what I'm going to follow up with today to give a bit more meat to what I said in that article. Let me start. I hope you can see my screen. This is, I'm sure you know BCSA, but just to recap, we're the trade body for UK and Irish steelwork contractors. They're our core membership, and we do have other members from the wider structural supply chain. This is me on the right. Slightly grayer now, I guess, but I'm sustainability manager at BCSA. I joined in 2022, and before that I was 20 odd years at the SCI, the Steel Construction Institute. I've just put a few logos on there. They're part of the BCSA group activities. We've got Steel for Life certification, our website steelconstruction.info, the Design Awards, and the NSC magazine. So all logos, hopefully you're aware of, all stuff we do at BCSA. Right, I'm sure you guys know this, but steel construction products obviously there's a wide range from rolled sections and channels and angles to rebar to coil, from which we derive a number of light gauge products, and plate and hollow sections. Our members, our steelwork contractor members, are mainly interested in these products, and of course what we do with them is we fabricate them. We cut, we drill, we weld, we paint them, and we erect them into generally quite large buildings. So that's kind of what we do, or our members, or our core membership does. Back onto the main sort of issue today that really has a bit of background or backdrop, is all the issues to do with climate change and global warming. I don't want to major on this too much, but just to show you maybe the scale of the challenge, you can sort of see where we are with global carbon emissions and where we hope to get to near 2050. And there are commitments, obviously, like the Paris Climate Agreement, which I think nearly 195 countries have now ratified now. And then in the UK, we have our own specific national legislation. So you can see the sort of challenging directory we're on. So that's really the backdrop for this, which is driving all I'm going to talk about today. So really the key message, I guess, is thinking a bit more about your project, and particularly its embodied carbon. We generally talk about embodied carbon at the building level in terms of kilograms of CO2 equivalents per meter squared of floor area. But I just want to think more about what that means in a global context. I apologize for the cheesy graphic there, but the point here is that these are complex global issues. Climate change is a global issue, and I'd like to encourage everybody, particularly clients of construction, to think a little bit more of this holistically rather than at a project level. Onto steel production then, and on the left is the sort of trajectory of steel making globally since 1950, and you can see the almost exponential growth since about 2000, shown in the pie chart. That's mainly driven by China. In 2022, we were just under 2 billion tons total global production, and that represents something 7 to 8% of global greenhouse gas emissions. Of all that steel, just over half goes into construction, so the sorts of products I showed you earlier. And then the big question we're kind of grappling with in the steel industry is in the context of decarbonisation, where is growth going? And we still expect, particularly driven by greater demand in developing economies, probably we're looking at another 30% growth on that 2 billion tons by 2050. So we've got that double challenge. We need to decarbonize what we currently do, and we've got growing demand, particularly from developing economies. Just to put that 2 billion tonnes into context, in the UK, we only produce around 6 million tonnes per year at the moment, which is 0.3% of that global total. A little bit more on demand then, and I won't dwell on this too much, but again, this is stuff we're working on, particularly with the I-D. Predicting future demand for steel is quite difficult, particularly in the context of climate change and decarbonisation. This is work by Cambridge on the right-hand side, and you can see a reasonable correlation between steel use nationally and GDP, and looking at developed economies like the UK and Canada, US, Japan, France in this graph. You can see we tend to stabilize at a stock of just under something like 12 tonnes per person within countries. After this, demand for new steel is for replacement and not expansion, and we can in theory at least meet that demand using scrap only. But so in countries like the UK, as we'll get onto later, we can transition to a scrap-based steelmaking quite easily because we have the supply, but that's more difficult in developing economies because the significant demand for new steel is going to come from those developing economies, other countries in Asia, in South America and Africa. So that's our challenge, of how we meet that growing demand whilst decarbonising how we do it. But even in developed economies, I think steel is going to play a vital role in the drive to zero carbon economy. I just put some examples of turbines and solar panels and hydrogen pipelines and nuclear power stations, energy from waste plants, all things that we're going to need steel for in the future. So I think demand will be growing even in developed economies for steel. So we can't just meet our low carbon targets by stopping making steel. We're going to need steel, so we're going to need to decarbonize how we make it. So on to carbon associated with buildings, and again, I assume most of you know these terms, but just to very quickly recap, we talk about embodied carbon. So there are all the emissions associated with the materials and the transport and the construction, including in use, maintenance, repair and replacement, and end-of-life demolition disposal. And then on the other side, we talk about operational carbon. So there are all the carbon emissions associated with heating, cooling, lighting, ventilating, etc. And then we talk about whole life carbon in terms of really the summation of those two terms. In the UK, we've focused very much on the right-hand side of the slide with Part L, the approved document Part L, and for many years this has sort of driven better operational carbon performance. We've seen less on the left-hand side. The Part Z looks very much like a real approved document, but isn't, but it's a proposal produced by the construction industry, or certain parts of it, to regulate embodied carbon. So I think, although it's challenging, this will be coming at some point, and that's really why I'm giving this presentation, to think how we can do that in the context of steel. A little bit in terms of I guess the mix of embodied and operational carbon. These data are a little bit old, as you can see, but probably the best data set from the UK GBC, it's the UK Green Building Council. And you can see that the purple colours here represent operational carbon. This is operational in relation to the operation of buildings and infrastructure, and the embodied carbon bit is relatively small. However, we have sort of seen over recent years the move or the focus shifting from operational carbon reduction to embodied carbon, and hence all the focus on steel and concrete, etc. I still think the focus should be more on operational carbon, because that is where the bigger gains are still to be achieved. Most of the reductions in embodied carbon achieved so far have been mainly down to decarbonising the electricity grid, rather than anything fundamental in terms of the fabric of buildings. And because we've got a lot of older buildings in this country, you know, we can't do too much with the fabric of those older buildings. So that remains a challenge, and I think really a focus on where we should be looking in terms of carbon reductions. Okay, moving on to where embodied carbon lies. In this case, I'm focusing in on a commercial office building, and this is from an organisation called Letty, who you may have heard about. But just to give you a feel for within a typical office building, where the embodied carbon in that building lies. And you can see the superstructure is almost half. That can vary quite considerably depending on what materials and configuration you're using, but you can see why a lot of attention is focusing on the structure and particularly the steel and concrete used to produce the structure. I use the term the modules A1 to A3 there, and without diving into the detail of it, on the right hand side here you can see the way we define the different modules when we do carbon assessments of buildings. So it goes through modules A, B, C, and D. We tend to focus in embodied carbon on more the front end, so modules A. But as shown again on the graph and the pie chart on the left, you can see, again, this is for a typical office building. You can see the 48% is the impact from making the materials, 48%. Then the other bits are mostly small, other than the maintenance replacements, which are modules B1 to B5. Don't want to dive too much into all that detail, which is in all these SEN standards, but again, just to give you a sort of a feel for the priorities in terms of embodied carbon and where we need to focus. And as shown here, they're mainly in terms of the production of the materials and minimizing maintenance and replacement impacts. Okay, on to steel then. Again, I'm sure many of you know this, but I never wish to sort of anticipate the audience. So in the steel making today, and emphasize the today bit here, is primarily, and it's 99.5% by either of these two routes. BF-BOS is blast furnace, basic oxygen furnace. It's the primary route. It's mainly iron ore, and it's reduced using coke. We do put some scrap in there up to something like a theoretical limit, about 25%. And that production route accounts today for around about 70% of global production. In terms of the carbon emissions associated with that to make steel through that route, it's of the order of 2 to 2.5 kilograms of CO2 per kilogram of steel. The other route, which is the balance, so around 30%, today it's mainly scrap-based. We're seeing more DRI, but I'm not going to cover that today. It's the secondary or scrap-based route. And as shown, the carbon emissions associated with this production route is much lower, 0.3 to 0.5 kilograms of CO2 per kilogram of steel. Back to our definitions then. We talk about long products in steelmaking, so that would be the sections and rebar, and we talk about flat products, all the things on the right-hand side of the slide. In terms of production routes for these different products, well, the reality is that all products can be produced using either of those two production routes. However, for technical, economic, and even historic reasons, some products are today preferentially produced by one or the other route. So as shown in the table, long products are equally well produced by either production route, whereas flat products are historically and today largely produced by the blast furnace route, and there's various technical reasons that I won't go into, not time today. But I would emphasize that that is changing. That is the situation today, but we're already seeing, driven by the whole carbon agenda, some more and more flat products coming into the market. We use environmental product declarations. Won't go into the detail of those today, but I'm just showing you three here. The two left are for plate, and the one on the right is actually for hot rolled coils. So they're flat products produced by the EAF route. They're not 100% scrap based, but this is starting to change. So we're seeing more and more flat products from EAF route coming onto the market. Just coming back to this slide, really, just emphasizing this difference. So if you were a specifier or designer and you were driven by embodied carbon targets, it would be quite an easy win to think, well, I'm going to go for the EAF steel because there's a factor of something like 5 to 8 difference between them. So it's almost a no-brainer, and it's what is happening in our sector today. So what we would call preferential specification of EAF steel. I would make the point, and not everybody would agree with me, that I would say EAF steel production isn't decarbonised steelmaking. It's making steel by a different route. One is ore-based route, one is a scrap-based route. Doesn't mean you've done anything particular to decarbonise those routes. So I wouldn't say that one's a decarbonised variant to the other. And there are unintended consequences of importing EAF sections to meet project level embodied carbon targets. This is a sort of a slightly UK specific issue in that our sections manufacturer is BOSS, and therefore to meet embodied carbon targets, we see imports of EAF sections. The consequence of doing that, although you might achieve project level meet project level embodied carbon targets, there is no net benefit in global greenhouse gas emissions, and I'll show you a bit more about that in a minute. And there are also other wider ramifications on the UK economy, and I'll show you a couple of slides on what I mean by that coming up. I'd make the point, and this is the central point as to why it doesn't make any difference whether you specify BOSS or EAF steel, is that all the common structural materials, concrete, timber, or steel, are all constrained to a greater or lesser degree. And so, for example, in terms of low carbon concrete, this is relying heavily on GGBS, which is ground granulated blast furnace slag, which is used as a cement replacement. The reality is that GGBS is a constrained supply, and we've seen in the UK us importing this from around the world purely to meet embodied carbon targets. It's a constrained resource. We're paying a lot of money to import it from around the world with no net benefit in terms of carbon emissions. So an example where you can meet project level targets using GGBS, and so we've seen examples up to 60–70% cement replacement. It's just crazy, really, because you're meeting a project target, but you're not helping the global emissions. Similarly with timber, and of course timber is a low carbon material, of course it is, and has some fantastic applications in construction. However, it's again a constrained supply. We don't have the land, certainly in Europe, to grow enough timber, and certainly not fast enough to substitute all the steel and concrete we use in our buildings. So again, it's a constrained supply. But then focusing back on steel, which is of course the main focus of today, just show you this graph, which has again come from the University of Cambridge, and it shows global demand for steel. To the left of the dotted line is historic, and to the right of the dotted line is predicted or anticipated out until 2050. And you can see the global supply of scrap, so that's the blue shaded area, is finite. It is growing as economies develop and mature. But today, where that dotted line is, the production split, as I've shown you, is something like 70–30. So the reality is, while steel demand exceeds scrap supply, specifying EAF on your project has no net benefit on carbon emissions. So that's the central message, really, that I really want to hammer home. And maybe if you have clients, maybe you wish to hammer home, because although people tend to understand the message, they tend to revert back to project level embodied carbon targets, which I'll talk about in a little bit. If we think about the different parts of that, so the blue is largely EAF steelmaking from scrap. and as I've shown, it's already relatively low carbon, but we can do more. We can decarbonise the electricity we use to do that, and that's already happening with products like X-Carb from Arcelor. But we also need to make sure we sort our scrap better, otherwise we're going to downgrade our scrap pool, and then we limit the opportunities for what we can recycle that into. But the more significant issue is this. So it's the primary production. So again, it's the today the blast furnace route, and this really is the priority. This is where 70% of steel is made, and this is where probably 90% of the global emissions come from. So this is the priority for the global steel industry, to decarbonise primary steel making. And there's loads of work going on to do this. This is EU data. It doesn't include the UK, but to be fair, the UK isn't doing too much in this space. But this kind of shows you a number of R&D projects being trialled throughout Europe. So there's a lot of great work, great initiatives. You can see the key on the left-hand side, a whole range of raft of different technologies and approaches being developed. And really just focusing in on this top right-hand corner here, probably the most advanced are these two technologies in Sweden. So, you know, it is happening. It is going to take time, and it's certainly going to take a lot of money. But the hydrogen DRI-based technologies are probably today seen as the most likely way to achieve net zero primary steelmaking. And really, it's the only way we're going to meet this global demand under the Paris Agreement that I've talked about. Just moving on then to slightly different aspect then. So we're thinking about, again, your project, and this time in a national context. And if we do end up being driven to import EAF steel sections to meet low embodied carbon targets, there are other ramifications of that, and this is what our members tell us. You know, there is potentially additional cost through less competition and for paying a low carbon premium with the EAF steel. There's increased delivery times for imported EAF sections, and there's also an issue of long-term security of supply of steel in the UK, but we don't really want to be purely dependent upon imports of steel, particularly in areas like defence. And linked to that, and so we're mainly focusing today on carbon, but of course sustainability is this broader context of social and economic dimensions, and I think we do need to be cognizant of the fact that there are ramifications of the added social and economic value that steelmaking in the UK makes. And I just use the example here from UK Steel, which is their UK Steel Charter, which quantifies the benefits of retaining steelmaking in the UK. So although we mainly think about carbon, and that really is the focus of the webinar today, there are broader ramifications that really need to be factored into decision making. Okay, on embodied carbon, and as I've said, time doesn't allow, and I'm not going to bore you with all the techie detail, but just show you some of the standards and guidance we use. There are many, but on the left-hand side are two EN standards. So the left-hand side is the one used to produce environmental product declarations. The next one in blue is how we do whole building embodied carbon assessments, and then the two on the right-hand side are important UK guidance documents from RICS and the ISTRAC-D that are really the main documents used in the UK to assess whole life embodied carbon. In terms of targets in the UK, we still only have voluntary targets. There have been several efforts to mandate embodied carbon reporting and setting of targets, but they've largely stalled. We wait to see whether the incoming government has a different view on that. But for example, we had this bill shown here, which failed to get very far. And as I've already shown you, we have this Part Z initiative launched, but again, hasn't been mandated in any form yet. The targets are largely based on whole building targets, so that's the operational and the embodied carbon side. terms of embodied carbon, they only focus on what we would call the upfront emissions, which are modules A1 to A5. You may recall I showed you those modules earlier. And the main targets which are voluntary used at the moment are the ones provided by LETI, REBA and GLA, or the Mayor of London. In addition to that, we have some, so they're whole building targets, but we do also have the I/D scores targets, which have tried to just focus in on the structure. I'll show you those in a minute. I would say the UK, despite being ahead of the pack, I would say over the last 20 years in terms of embodied carbon, in terms of regulation, has slightly fallen behind other European countries. And this is just a snapshot of, for example, of other European countries who have taken steps or are in the process of mandating, regulating embodied carbon. So it is happening in the rest of Europe, and I would think highly likely that at some point it'll happen in the UK. So these are the targets then. So I've mentioned REBA, that's the block on the left, LETI in the middle, and GLA to the right. These are targets for, or they're benchmarks really, for office buildings, and you can see they ramp up as we get towards sort of 2030. So at the moment we're sort of looking at something like between 350 and 550 in terms of kilograms of CO2 per meter squared of floor area. That's for new build. And I mentioned the I/D scores one. So this is structure specific. So they've taken out the rest of the building, and these just honing in on the sub and superstructure. And these are slightly more tougher. They're actually based on the LETI whole building embodied carbon targets, but they are structure only. And you can start to see here, if we look at 2030, the target is something of the order of 150 kilograms of CO2 per meter squared just for the substructure and superstructure. So that's starting to get quite challenging for all structural forms. And as we get to 2050, it gets significantly more challenging. One other initiative that is nearly ready and is likely to supersede all the voluntary targets is this net zero building carbon standard. It's been in development for a couple of years now. It's linked to this built environment carbon database, where you can find a lot of data on the embodied carbon of a number of buildings. And these are the benchmarks that this project has derived. So for different building topologies, if you look at the mean values here, you can sort of see what we're currently achieving for the different building types. Again, this is upfront A1 to A5, and it's CO2 per meter squared of floor area. So these are the benchmarks, what we're achieving today. But this project is, I literally just received the drafts of the standard a couple of days ago, and the new targets will be issued in about a week's time. So they're going to be very important, because these are sort of bottom up, what I'm showing on the screen here, but the top down targets are coming from the UK carbon budget and where we need to be by 2050, so likely to be significantly lower than the sort of mean values showing on the slide here. A different approach to specifying, and this is something BCSA we're supportive of. It's not our suggestion. It's been proposed and supported by several organisations, including Responsible Steel, Steel Zero, CRU, and ArcelorMittal support it. And very quickly, what this graph shows is that on the x-axis is the recycled content in steelmaking, and the y-axis is the carbon intensity of making crude steel. So not the finished product, but making the crude steel. And every dot on there is a steel mill from around the world. So you can see the grouping to the left is all the blast furnace mills, the integrated primary steelmaking works, and the group to the right is all the EAF near 100% scrap-based mills. And this approach is more cognizant of the fact of what I've been showing, that it reflects the fact that all steelmakers need to decarbonise. So as I've explained with the global context of this, it's no point just specifying EAF steel. It doesn't solve the problem. We have to decarbonise these mills on the left of the figure, and this sort of approach incentivises all steel makers to decarbonise. And it's being picked up by Steel Zero, if any of you are Steel Zero members or thinking of that. So Steel Zero is for users of steel and is intended to send a message to steel makers to decarbonise through procurement. And Steel Zero propose this performance level 2. These are the responsible steel progress levels. So anything better than level 2 is what Steel Zero wish to do. And in terms of, this is their recently published 2030 commitment. So if you sign up to them, you commit that by 2030 you will procure a proportion of steel in that blue sort of triangle. And we're supportive of this because what it does is, instead of incentivizing specifying steel from A as opposed to B, it incentivizes specifying steel from C as opposed to D. So the intention here is that we're taking out the recycled content aspect of this, and we're incentivizing steel makers on the same vertical dotted line in this case. So we're moving away from A to B, and we're incentivizing specifying C over D. Despite this global view, we're cognizant that clients and some of the consultants are still very keen to adopt embodied carbon targets at the project level. And if clients insist on that, we would recommend using a blended approach. I'll explain that in a minute. And that would involve using a mix of BOSS and EAF, and even some reused steel if appropriate. And that's what we call it, sort of this blended approach. The iStruct use a similar term. They call it a bounding approach. And I've just taken a snippet out of the iStruct guidance there. So they support and recommend that you use this bounding approach to meet embodied carbon targets, should you choose a product level embodied carbon target. And this is one way I've been trying to promote of doing that. So just very quickly, what we're doing here is trying to uncouple structural efficiency. In this case, it's the primary steel structure only. I haven't included the floors or anything else in this, but we're purely looking at steel superstructure. And what this does is has structural efficiency on the x-axis and carbon intensity using the same metrics as would be in LETI and other voluntary targets. And in this case, there's your little project. So this time we're coming in at a structural efficiency of 55 kilograms per meter squared for this particular project, and we're coming in with an embodied carbon intensity of 93. So ideally, your project should fall within that envelope created by those two dotted lines. And we think this is better because we have this range of BOSS and EAF for the structural sections. At least by doing this, we're incentivizing better design before we start thinking about whether we specify EAF or BOSS steel. So what this little tool that sits behind this graph does, it will tell you the split of BOSS EAF on your project that you would need to achieve that 100th, that orange dotted line. So this is the approach we're adopting, and it's being supported by SCI in terms of some design guidance they're about to produce. But in reality, is that why we want to do this is because in the current market, we see projects at, and these are extreme and they're hypothetical, but projects at A being chosen over projects at, say, B. And we think this is crazy. You need to get your weight or your structure as efficient as you can. It's too easy to just meet embodied carbon targets on their own by just specifying EAF steel. Whereas, as you can see at B, we're looking at a much lower steel weight and using BOSS steel here. So at least this approach sort of makes that more transparent, so we can focus in on the structural efficiency first. Just to give you a feel, we've mentioned EPDs. And these are 3 of them. Of course, there are many others, but just to show you from left is the British Steel sections EPD from the BOSS route, so 2.45. Then we have the EAF from ArcelorMittal. This is not just the EAF, this is EAF X-Carb, so it's got renewable electricity in this, so it's down at 0.3. And then on the right-hand side, we've got the reuse, and this is a new EPD from Cleveland Steel and Tube. So, you know, these things are out there. So if, and I emphasize, if you're going to be working to a embodied carbon target at the project level, we do have the constituent parts here that you can choose to achieve that target using a blended approach. Just to go back to this, and you know, I say the A and the B here is hypothetical, but it is in reality happening. So for example, and again, these are theoretical and relatively extreme, but it is real. A could be EAF rolled sections, and B could be a very structurally efficient plate girder, and we're already seeing sort of mothballing of you know, plate girder lines in the UK purely because of the embodied carbon arguments, whereas in terms of structural efficiency, they're actually a very good solution on some projects. Another issue that is the early design stage embodied carbon assessment. So this is, well, what would you do at day one if you were conceptually designing a building? And of course, you wouldn't know the specific supplier at that early design stage. The guidance in the UK in these 2 publications is to use UK industry standard practice. And in reality, that means for hot rolled sections, the I-Struct recommend using a UK consumption average value, which we've derived at BCSA, and RICS recommend a UK blended market rate of 60/40 BOSS EAF. In reality, they're not that, the actual values that fall out of those recommendations are not too different. But just to show you this, which is the latest value that we've calculated at BCSA, we published it in 2021, and the market average mix in the UK for structural sections in 2021 was 1.74. We've updated it last year, and that was published in the NSC in last month. And you can see we've dropped a little bit, 1.64, that's a 3-year average. It's very sensitive to domestic market share, so the British Steel primary steelmaking market share, but that is the value that we're recommending using now. And the I-Struct are updating their guide, so this one on the left here this year, and hopefully they'll include that 1.64 value in there. Just by way of, just to really finish up this part, is just to show you a little example of what these numbers mean. And this is a building we've used in the steel industry for several years now to do these sorts of comparison. It's an 8-story office building. In terms of facade, it's a bit outdated now, but structurally it's fine. It's 16,500 meters squared floor area. Relatively long grids, arguably for today, 60 minutes fire resistance. And for this building, which was designed by Peter Brett Associates, we're focusing on 2 structural options, so a cellular composite beams and concrete floor slab, the steel, primary steel weight of 60 kilograms per meter squared, and we compare that with a post-tension band beam and slab option. Just going back to this, and you've seen this, but the sorts of targets we're looking at. So I've shown you the LETI targets. Superstructure is roughly half of that. So at 2030, these are the sorts of targets that the big consultants are sort of working to. So a whole building target of 350, superstructure something of the order 170, and when you add the sub and the superstructure together, something 230. So it depends on which interpretation isn't this granular of the LETI targets, but these are the sorts of figures, and we've spoken to a lot of structural engineers. These are the sorts of figures that are currently being worked to. So for this building then, we've done an assessment. we haven't done the facade because that isn't relevant to the main structure, but the scope is substructure, frame, upper floors and roof. And we've looked at 2 scenarios. So we've looked at an average embodied carbon scenario, and we've taken those embodied carbon factors shown on the screen here directly from the I/D guide, table 2.3, if you want to find them. So that is our average embodied carbon scenario for today. And then we've also really ratcheted it up to say, well, how far could we go if you were really going, pushing every sort of low carbon button? And again, we've used the I/D guidance there, but for the red ones shown here, we've used the X-carb figures. So for the rebar, for the steel decking, and the sections and the plate. So using those values, this is what we come up with. So on the left-hand side, you've got the steel variance. So the blue is using the average embodied carbon scenario, and the grey is what we could do if we absolutely cranked up using the values in the box here. And the right-hand side is comparing that with the post-tensioned option and doing exactly the same. So putting in more GGBS in the concrete and using low carbon rebar, etc. So you can see, we're not a million miles away today, but we are able to meet the so I should say this is both the sub and the superstructure. So we're well beneath the sub and superstructure target, and just showing you where we can go, even with products available in the market today, particularly using the X-carb variants. So we could get down to somewhere near 50 kilograms per meter squared for the superstructure. Just to finish up then, conscious of time, I just was going to run through stuff that BCSA and the sector is doing. We're doing lots of stuff, of course, and the environment keeps changing, but we really, I guess, in terms of carbon at least, we hang our strategy all around this, which we launched in 2021. We launched with the minister at the time, Lee Rowley, and this is really centered on this waterfall, and we look at sort of 3 main blocks within this waterfall. So this is where we were at 1990, which is the benchmark for UK government 2050 net zero target legislation, where we got to in 2021, and then the things we think we can or should do to get to near zero in 2050. And we look at the first 2 levers. We call these levers in our strategy. We get demand side levers, we have supply side levers. So this is the steel making, and then the little bit on the end is really the BCSA, the Steelwork contractor members' contribution to that. So very quickly, things we're doing, and this isn't a comprehensive listing, but in terms of design efficiency, we have a sustainability annex to Annex J to our NSSS, which deals with sustainability aspects. We've been working on this for some time with SCI. We're about to produce a new guide, SCI guide P449, and that is all dealing with how we can improve design efficiency to achieve carbon savings, and they're the sorts of things this guide will cover. And just really to flag that SCI is running a design course on this new publication in a couple of weeks' time. And we predicate that on this, which again we've borrowed from I/D. So this is their hierarchy. So that SCI design guidance is all about focusing in on where, as designers, you can make a difference. So following that hierarchy, and really only once you've done all that, think about specifying low carbon. So this is kind of the approach we're adopting, and the SCI guide has adopted. Moving on then, circular economy means lots of things. It means things in terms of steelmaking, but particularly in our sphere, we are particularly interested in and doing a lot of work on steel reuse. BCSA has set up a steel reuse working group. There's obviously lots going on in this space, particularly in city centres and particularly in London. And there's a raft of stuff coming out, again, largely SCI. So we've got the two on the left-hand side are design guidance to reuse existing steelwork. P4 to 8 is all about designing for the future. This is particularly demountable composite flooring systems. And then on the right-hand side, SEN is in a sense following what we did in P427, and there's a new technical specification being developed under SEN Technical Committee 135, which is out for formal vote. So a load of stuff in the reuse space, and I think we're going to see a lot more of that. The whole presumption in favour of refurb and the retrofit first movement, I think, is both a threat and an opportunity for steel. Obviously, it's going to mean less new build, but I think most of these buildings that are being refurbed and retrofitted, steel, there's some fantastic opportunities, and we've seen some great projects coming out, again, particularly in London, of what steel can do to refurb and extend the life of existing buildings. So more and more of that, I think, is coming. The more important bit, arguably, so the biggest slugs of the waterfall here are all to do with the supply side, and by that we mean steel making, and we're looking really in three areas: about direct steel making emissions, about grid decarbonisation, and that's obviously linked to the transition to EAF, which you're probably aware of, but is also affected by the high UK energy price. We still pay, or industry still pays something 50–60% more than, for example, in France and Germany. And the last one on here is carbon capture, use and storage, lever 5. Work is underway, but still some way out, I think. In a sense, in the UK, if we transition to EAF, in a sense, the argument for CCUS goes away in the UK anyway. So most of the reductions under levers 3, 4, and 5 will be through the transition from BOS to EAF and achieving those lever reductions 3 and 4. There is loads going on at the back of the roadmap. There was a comprehensive listing of stuff going on in terms of new technologies and R&D and new pilot studies. Fair to say that the UK is falling somewhat behind, particularly our European neighbours, in terms of some of the advanced technologies like hydrogen, DRI, etc. But of course, we are in the transition stage and transition from BOS to EAF, which is a major step for the UK. So on that, then, in terms of the three main suppliers to the UK market, just really a couple of slides on each of those. British Steel has committed to science-based targets. Of course, they're aligned with the 2050 net zero carbon target, and they do look to achieve an 85% reduction by 2026, which seems quite staggering, but fingers crossed they do that. And of course, that's, again, as I've already said, in connection with transitioning from blast furnace steelmaking to electric arc. And this is just the plans for Scunthorpe. The EAF proposals are to have a new EAF mill at Scunthorpe and at Teesside, and planning permission for both has been granted. Negotiations with government are still underway to secure the funding, and that's been somewhat held up by the change of government. But these are the plans. So Teesside and Scunthorpe to have a new 130-ton EAF mill, and there's significant benefits to that in terms of a process. And just to note at the bottom, this is the sort of capex investment which is being looked for, and hopefully with a new government we can get that secured and get these EAFs installed. And if we do, this is the trajectory that British Steel will be on. So you can see the significant drop as they transition from BOS to EAF from 2025 to 2026. Some skepticism is it'll be quite that soon, but it certainly should happen. And then subsequently, we're looking at decarbonising the grid to further reduce it to something like near zero by 2035. In terms of Arcelor, slightly different situation. Their commitments are slightly more modest in the short term, since they already are a large EAF producer, certainly in Europe. so they haven't got that step change technology, but they are doing some really interesting work in a number of the key areas that I've touched on, like CCUS and hydrogen and bioenergy, all these things. So their trajectory is somewhat smoother, shall we say, to 2030, after which there's some significant drops, particularly in terms of the DRI hydrogen side of things. And lastly, for Tata, it's a very similar situation to British Steel. So here are their commitments, and similar sort of commitment. Of course, they're mainly a flat product producer, so they will probably be looking at something like 75% scrap, so they'll still need some primary iron ore iron units in their works, but their product offering, as we've been told, will be the same, and their transition is slightly further out, but similarly sharp. So you can see, as you've probably seen in the press, already switching off the blast furnaces, but the transition will be when they get their EAF up and running at Port Talbot, and this is what their timeline kind of looks like, hopefully going forward. So slightly further out than the British Steel, but Tata Steel is slightly more advanced with government negotiations. So we'll see who gets there first. And the last little bit, and this is the end for me, is lever 6, which is relatively small, but it's the additional impact that steelwork contractors add to the carbon footprint, if you like, of the whole supply chain, and stuff we've been doing. I've mentioned the Annex J and the NSSS. We run a sustainability charter that most of our members are signed up to. We've developed in-house carbon footprint tools, and many of them are on with doing embodied energy efficiency and renewable work. And we're focusing on the CBAM and the implications that that will bring to the sector. Only picking on just one of those, this is the charter. So I've said we've updated it after I joined BCSA. It's a bit tougher now, but I think that's the right thing to do. So 50 or 60 of our members currently have the charter. We don't just cover carbon, we cover the full breadth of sustainability. So there are 15 requirements. So to meet it at gold level, you've got to achieve all these sorts of things. So it's a real positive, much broader than just carbon, but includes carbon, but showing that our members are sort of doing their bit in terms of sustainability and carbon. And just to show you some examples there. So that was it. I'm just very quickly summarizing, if I may. Think about the wider implications of project level embodied carbon targets. Supply constraints, global supply of steel and GGBS and concrete and timber are all important, and you need to bear these things in mind. You know, we simply can't substitute all the steel and concrete we use just by using timber. There's just not enough of it, so you need to bear those things in mind and the decisions you make at a project level. I would advocate focus on areas where you have the expertise and experience, and for designers, that's all about designing better and using less stuff. I think that's Will Arnold's phrase, not mine, but that's where we would encourage them, and hence the SCI design guide that's about to be published. We would promote early engagement with supply chains, particularly our steelwork contractor members. They've got the experience. If you're thinking of reuse, and that early engagement is very important. And also, okay, we're thinking about the here and now, and clearly we have an urgency to address the climate challenge, but we also need to think about the future and do what you can to think about the future design for circular reusable buildings, and that's an easy win for steel construction. Encourage you to exert pressures on steelmakers to decarbonise, so initiatives like Steel Zero, which I know many or several BCSA members have signed up to, but please be realistic about timescales. You know, we can't have zero carbon buildings tomorrow. This is a massive change for the steel industry to transition to, in the first instance, to EAF, and then to move on to DRI and hydrogen and other technologies. It will take time, it will take a lot of money, so you know, please be mindful of that. And finally, hopefully, as I've shown you, we have a plan as a sector. BCSA is sort of leading on this. and our roadmap, we're sort of delivering it, and we will be reporting on it in the next couple of years to show how far we've got from when we published it in 2021.